Okay, so that's started. So I'll just start off with sharing my screen. Okay, yeah. So that's a fresh page. Okay, so is this visible to everybody? Can everybody see the ice cream? Can everybody see this? Can everybody see the blank page? Yeah. Okay, fine. So
Yes,
yeah.
ma'am.
Okay, good. So I will just start off now. So what did we actually, kind of realize before we broke for lunch is that, yeah, so let me just admit a few more people. All right. So we essentially realize that your linear harmonic, so basically we were looking for this solution, right? Yeah. And what we realized is that if E is a known eigenvalue, okay, then essentially E plus h cross omega, E plus 2h cross omega, okay, and so on are also solutions, right? Are also eigenvalues. Additionally, what did we realize? Just one second, I need to admit a few more people. Okay. Apart from that, we also realized that E minus h cross omega, E minus 2h cross omega, and so on are also eigenvalues. Okay. And what we realize that the energy eigenvalues, okay, or energy eigenstates which give those eigenvalues, all right, they form a ladder. All right. So they form a ladder. All right. So you have essentially your your E plus h cross omega, then you'll have an E plus 2h cross omega. I have not made the steps look very even. I'm sorry about that, but I hope you can see this. And then you have E minus h cross omega. We have E minus 2h cross omega, and so on and so forth. Okay. This is how it looks. And the step size is always h cross omega. Your A plus makes you go upwards, your A minus makes you go downwards. And that is why the A plus is called the raising operator, the A minus is called the lowering operator. And the discussion that we were having just before we broke was that we cannot keep going down as many times as we wish, right? Because finally we hit the ground state, and by rights we cannot lower below the ground state, below the ground state. Okay, so it is, you can well imagine, it is like you have put a ladder, or you have a staircase. If you remember, there's a staircase in the department. I know we had a very short sojourn in the department so far. Hopefully things will change. Okay, and you know that you can keep going up, and also when you come down there is a point below which you cannot go down, right? That's when you have reached the ground floor. Okay, so the question is, how do we represent this mathematically? So let us imagine that the ground state, okay, and as somebody very well correctly said, which is associated with the minimum energy. Okay, minimum energy means you cannot go below that. It is associated with the minimum energy. So we'll call this minimum energy E naught or E0. Okay, and the ground state, of course, will become this. Okay, so everybody agrees with this, that there is a minimum energy which we are calling E0, and the ground state is the state which has that particular energy. Okay, it's an eigenstate of the Hamiltonian. It is an energy eigenstate, and it is associated with the minimal energy. Now, what we have to ask is that if I do this, what will I get? What will happen? Okay, yeah, and you know that this operation should be such that it should become, make it, and it should invalidate it. Okay. All right. So how do you invalidate it? You basically say that this goes to a null vector. Okay. It goes to a zero, a null vector. All right. So this is what we have to essentially say. Now, this is a very, very important thing. Okay. Because what you have to realize is that we can keep climbing. So there is no upper limit to the energy. Okay. There is no upper limit to the energy state. All right. However, there is a lower limit. All right. Now the question is, what is the value of E naught? Okay. What is the value of E naught? And what you will realize is that once we know E naught, then we essentially know all the energy eigenvalues, right? Because then what do we have to do? On the state that is associated with E naught, we apply A plus. Okay. And then what will be the next energy? It will be E naught plus H cross omega. Then you'll have E naught plus 2H cross omega plus E naught plus 3H cross omega. And you'll just keep on going like that, right? So we know the energy eigenladder. But the question is, what is the value of E naught? How do we find it out? Okay. So that is our next question. So let's do that. So what we will do, okay, so you know that, so we will start off with this step. Okay, we'll start off with this step. We know that A minus E naught is equal to 0. What we will do now is we will operate on both sides with, so just, okay, we'll operate on both sides with H cross omega A plus. Okay, so we will operate with this. So let's do that. So on the left hand side, just 1 second, I need to admit somebody else. On the left hand side, we will have H cross omega A plus A minus E naught. On the right hand side, what will we have? We'll still have a null vector. Okay, because anything that operates on a null vector becomes a null vector. So we'll get again 0, right? Remember, this is a not just a ordinary 0, it's a column matrix, okay, of zeros. All right, that's why I'm calling it a null vector. Now, this means what? All right, so we will now have to essentially write down, we will have to use one of our earlier, what do you call it? Formulae which we came through with earlier. Okay, and what was that? So let me just remove the implies that, and we will write it down over here. It was essentially that your Hamiltonian is equal to, if you remember, H cross omega A plus A minus plus half. Now you remember Tejashri had asked me this question about the n. Just 1 second, I need to admit some more people.
Yes, ma'am.
Yeah, so I'm going to basically now, so remember that this is the special operator called n. All right, yeah. Oh, it's not come out properly at all, so I will write it on the top. Okay, this is this operator called n. All right, so I'm going to use this actually. Yeah, so if you look at it, this can be written as H cross omega A plus A minus plus H cross omega by 2. Correct? Yeah, so this is what we have. So let me now go on to the next page. Okay, there's still 2 more people who have joined. Just hang on a second. Let me admit them in. All right. So now what do we have? We have essentially, just a minute. Yeah. So we have, let me write down, oops, sorry, I'll have to change the page. Your Hamiltonian is equal to H cross omega A plus A minus, okay? And then what you have? You have a minus h cross omega by 2. It was minus, right? Let me just quickly see what I have written earlier.
Plus 9.
It was plus. So, yeah, it was plus. Okay, right. So now, oh man, okay. I think Santosh is having a bit of trouble getting in because I'm seeing, oh boy, all right. All right. So now what we can do is we can write this h cross omega a plus a minus as h minus h cross omega by 2. I hope everybody is okay with this. Yeah. Now, in the meantime, you remember what we had written in the earlier page. We had written h cross omega a plus a minus acting upon this e naught is going to give you 0, the null vector, right? So now we will replace this h cross omega a plus a minus as the Hamiltonian minus h cross omega by 2. Okay, e naught is equal to 0. Yeah, which implies that the Hamiltonian acting on E naught minus h cross omega by 2 acting on E naught must be giving us the null vector, correct? Which implies that E naught, right? Hamiltonian acting on E naught will give us E naught, the minimum energy, minus h cross omega by 2, E naught must be equal to 0. So we will thereby write it as E naught. This is the number E naught, okay? The minimum energy value. This is the eigenstate E naught. Please remember there's a difference between the two, is equal to 0. Now we have two options here, right? One option is that your E naught itself is the null vector. Okay, so this is the null vector. Or your E naught minus h cross omega by 2 is equal to 0. This is the number. Now, since we think that there is a minimum state, okay, there is a minimum state. So that cannot be a null vector. Okay, so we cannot take this option. All right, because the minimum state exists. Here we are, if we are saying it's a null vector, we say there is no minimum state. That's nonsense, right? Yeah, or it's an invalid thing. Minimum state is invalid. It makes no physical sense. So thereby we cannot take the first option. So we have to take the second option, which implies that your E naught is equal to h cross omega by 2. This is an extremely interesting result. It tells you that the minimum energy of the quantum mechanical linear harmonic oscillator is not 0. It is h cross omega by 2. Okay, so this is, some place where you can say quantum mechanics is essentially astonishing. And where does this actually originate? If you think about it, it originates again in your uncertainty principle between position and momentum. Okay, because of that you will have a minimum energy associated with the ground state. Okay, so please remember, a linear harmonic quantum mechanical oscillator cannot have a minimum energy of 0. It's impossible. It has a minimum of energy of h cross omega by 2. Now what do we do? What are the other energy eigenstates? So we have the ground state energy. What are the other energy eigenstates? The other energy eigenstates, okay, what are they going to be? E naught equal to h cross omega by 2. Then we can have E1, the first, which is going to be h cross omega by 2 plus h cross omega, correct? So which is going to be, what is it? H cross omega into 1 plus half. There's a reason why I'm writing it like this, okay? E2 is going to be h cross omega by 2 plus h cross omega plus h cross omega. Or we can also say it is equal to E1 plus h cross omega, or E0 plus 2h cross omega. So it is going to be nothing but h cross omega into 2 plus half. Okay. Then E3 is going to be, either you can say E0 plus 3h cross omega, or you can write it as E2 plus h cross omega, whatever way you want, or E1 plus 2h cross omega, it doesn't matter. This is going to be h cross omega by 2 plus h cross omega plus h cross omega plus h cross omega, right? Whatever way you want to write it, it doesn't matter. But the answer is finally, h cross omega into 3 plus half. Okay. So what does this tell us? It tells us that your nth energy eigenvalue is going to be n plus half into h cross omega. Okay, where n is a positive integer. Okay, so this is again a very, very important formula. En is equal to n plus half h cross omega. So we have the energy eigenvalues of the linear harmonic oscillator. Now you will be able to see when Meera ma'am solves this that you will arrive at exactly the same answer, of course, right? It's the same physical system. Just because the method of solving it is different, you shouldn't end up with different answers. You will end up with exactly the same answer, but it will be a much more complicated method. All right. Now, once you have the energy eigenvalues, your next question is, what about the energy eigenstates? I have the energy eigenvalues, but what about the energy eigenstates? Now, what you will realize is that we don't need to solve for them explicitly. You can, it's a bit more painful here, but we don't need to solve for them explicitly. So let me just show you what are your energy eigen. So let me write it, energy. Just give me a minute. I think I need to just pad up my iScribe with more paper. It's taking a bit too much. I should have done this before the class. Okay. Hopefully it will come at the same. So remember, energy eigenstates, okay, are equivalent to same as energy eigenfunctions. Okay. Sometimes I'm using the term energy eigenfunctions. Same thing as energy eigenkets. Okay. Please don't get confused if I'm using different terms at different times. Okay. It is the same thing. All right. So we are going to ask now. So we know the energy eigenvalues and what were they? So we know already energy eigenvalues were essentially what? E naught, E naught, okay, plus h cross omega, E naught plus 2h cross omega, and so on. What were we calling these? This we were calling as E1. This is E2. Okay. And somewhere along the line, we will have E naught plus n h cross omega. And this we will call as En. Correct? Yeah. And what is this? This is nothing but h cross omega by 2. This is 1 plus half h cross omega by 2. So it will write it as 3 by 2 h cross omega. This is going to be 5 by 2 h cross omega dot dot dot, and you will have here n plus half h cross omega, right? Yeah. Now, just one second. I'll have to admit a few more people. Okay. And now the question is, what are the eigenstates? This was, of course, E naught. Then associated with this is associated with this. With this is associated A plus E naught, right? With this is associated A plus operated twice on E naught. Okay, and we can go on like this, and here we can say it is A plus operating n times on E naught. So just by operating A plus several times, you can end up getting your different eigenstates. All right. Now remember that these are right now not normalized. Okay. So we'll have to do some tricks. Okay. So remember, while just doing this operation, okay, this one is normalized. Sorry, the E naught is normalized. We will assume it is normalized. But then when I do this, it is not normalized. So question is, how do we normalize it? Okay, so we have to find out what is the normalization for this. So everybody understands, right? You have to multiply some constant such that the state becomes normalized. Okay, so we will now find out how to go ahead and normalize it. All right. So let us imagine. Okay, so let us imagine we have En. Okay, so what is this En, please? It is the nth energy eigenstate. Okay, of what? Of course, it is the linear harmonic oscillator, quantum mechanical. All right. What is the energy associated with this? En must be equal to n plus half h cross omega. Okay, so there is a point which I kind of didn't mention to you. I will say it later. All right. Now, what? Yeah. So what we assume now, okay? So assume that this En is normalized. Okay. We'll just assume that the En is normalized. Okay. If En is normalized, then we want to find out what is the normalization constant for the En plus 1. Okay. So if En is, then what is the normalization constant for going to En plus 1. Okay. How do I am going to go to En plus 1? I want to go to En plus 1 from En by operating A plus. Okay. And I know I will end up going to En plus 1. But I need to multiply something over here so that it is normalized. Okay. So question is, what is that multiplication? So we will call it some C, okay, which is a number, but we need to specify this C. So we'll call it C with a subscript of n plus 1. Okay. Now let us, so here we have written the ket vectors, right? These are the ket vectors. Let us write down the bra vectors. Okay, so when we want to write down the bra vectors, what will we have? We will have essentially En going to En. But then what happens to A plus? You have to take the A plus dagger, right? The transpose conjugate of A plus. What is that, please? Can anybody tell me? What is A plus dagger? What is it?
A minus.
A minus.
Very good. It's A minus. So I'll get A minus is equal to, and here I will get En plus 1, of course. I'm going to get the corresponding bra vector. And what will I get over here? Cn plus 1 or what? What will I get? Is this correct, what I have written?
En plus 1 dagger, ma'am.
Dagger for a number you will not get, no, ma. So what will you get over there? You're on the right track. But what For a number, will I get dagger?
Star, ma'am.
Star. Perfect. Very good. Okay, so we'll get a star. So I'm very happy. Everybody's paying attention. Wonderful. Okay, you got A minus, you got Cn plus 1 star. That's really nice. Okay, now let us try and work out what is En plus 1, En plus 1. Okay, yeah. What will this be? Okay, I think I made a mistake. Just give me a minute, please. Okay, I think I wrote it the other way around. All right. Okay, so let me just, yeah, I will change this. Okay, I'm going to change the step. This Cn plus 1 actually was put over here. Okay, Cn plus 1. Can everybody see it? Okay, all right. So we have put it like this. It doesn't matter. All we know is that there has to be an extra number so that this Cn plus 1, this En plus 1 eigenket is also normalized. So now what will happen? We will not get a Cn plus 1 star here. We'll get a Cn plus 1 star here. Okay. Either way, if you change it from a ket to a bra, you remember that you have to multiply with the corresponding complex conjugate for the number. All right. So I'm going to write this step again. Okay, I'm going to write this step again. What have we done? We have defined this En plus 1, okay, as, of course, it has to be A plus En, but so that this guy is also normalized, assuming that En is already normalized, the inner product is 1, okay, we multiply this with the Cn plus 1. When we do the we get a Cn plus 1 star, and then we get this, and we get an A minus. Okay, all right, everybody with me? I'm sorry for creating the confusion. I hope everybody's got this. Okay, now is everybody okay, or I've confused everybody very badly? I'm sorry about that. Is it okay?
Yes, ma'am.
All right, fine. So now what we want to do is we want to get this, right? En plus 1, En plus 1, the inner product. Now that will be nothing but, let's write it down. We'll have a Cn plus 1 star. Okay, we'll have a Cn plus 1. We'll have an En A minus. Then we'll have an A plus En. So we will have over here mod Cn plus 1 square En A minus A plus En. Is this clear to everybody? Has everybody got this? Yes?
Yes, ma'am.
Okay. So now let us write down this A minus A plus. Okay. I still have to answer your question about why A plus A minus was special and called in. Just give me a little time. I should have done this before. Let me finish this normalization constant and we'll go back to that. Okay. So now, what do we use over here? We will use this expression. The Hamiltonian is nothing but h cross omega A minus A plus, and if you remember, this was a minus half. Okay, there was a A minus A plus minus half. Okay, I hope everybody remembers this. So we are going to use this expression. So now I'm going to change my page. All right. Just 1 second, somebody else to admit. So when I've changed, so what I will have to write now over here is that I have to write down. So let me just go back to that expression once again. I'm just writing it again. I'm sorry, a lot of repetition in my notes. Okay, what was it? A minus A plus minus half, right? So let's open it up. This is going to be H cross omega A minus A plus minus H cross omega by 2, which implies that, okay, so let's now, your H cross omega A minus A plus is going to be nothing but H plus H cross omega by 2, right? Yeah. So then I want only, of course, A minus A plus, right? So I will write this as A minus A plus is equal to H by H cross omega plus half. This is what I'm going to use. All right. So let me repeat what step we were at. We had found out that this En plus 1 was nothing but mod Cn plus 1 whole square. And then what did we have? We had En, and then we had this A minus A plus En, correct? So this A minus A plus I'm going to replace with this. All right. So we will get now mod Cn plus 1 square En, and then we have H divided by H cross omega plus half En. Okay, I hope everybody is with me so far. Now let's see what we get. So this is going to be thereby mod Cn plus 1 the whole square, and then we can write it at, let's make a big bracket. We will have here En H by H cross omega En plus half is just a number, so it will just come out En okay, which is going to be nothing but mod Cn plus 1 the whole square. And here we will get now 1 upon H cross omega, right? Then we get En H En plus, what is this? We know this is 1 because we started off assuming that En was normalized. So this is going to be just half. What about here? We know that H acting on En gives us En, right? So let me just write it down here. H acting on En will give me En, correct? What is this En? This is nothing but N plus half H cross omega En, correct? So let's now put this value here. Okay, so therefore your En plus 1 is equal to mod Cn plus 1 the whole square into 1 upon H cross omega, and then we have over here you have N plus half H cross omega En plus half, right? So this is going to be now mod Cn plus 1 the whole square. I'm taking too many steps, but it doesn't matter. This is now just a number, right? So I can take it out. So I can have over here N plus half H cross omega divided by H cross omega, and then I'll have En plus half. So what is this going to be? Mod Cn plus 1 the whole square. Your H cross omega will cancel. You will get over here N plus half. This is nothing but 1. So we will ignore it, and you will get a plus half from here. So you're going to get C mod of N plus 1 whole square into N plus 1. Right? So what does it tell you now? It tells you that if you want mod en plus 1 to be equal to 1, we want it to be normalized. It implies that mod Cn plus 1 whole square into n plus 1 must be equal to 1, which implies that Cn plus 1 must be equal to, what is it? 1 upon n plus 1, the entire thing to the power of half. So in other words, it's equal to n plus 1 to the power of minus half. Okay. So what does this tell us? Which essentially tells us, let me just put this away. It essentially tells us that your mod of en plus 1, if you remember, we had started off with this, right, is equal to Cn plus 1, then A plus acting on En, right? This is what we had, if you remember. So this now, your Cn plus 1 becomes n plus 1 to the power of minus half A plus En. Okay? Or we could write it as A plus, also this could imply that your A plus acting on En is equal to n plus 1. You can take it to the other side, power half En plus 1. This will ensure, okay, that, what does it ensure? It ensures that your En plus 1 will also be normalized. Okay? If you define your operation, raising operation like this. Okay, this is what it shows. So now, yeah. So both these things are extremely important. This also is extremely important. Okay, you need to remember both of these. One follows from the other, so it's not a problem. All right. Now, let us go further. Okay, we need to figure out certain things. So as you can see from here, I'm going to repeat this step. En plus 1 is equal to n plus 1 power half A plus En. Correct? Now replace n plus 1 with n. So which means you have to take away what? 1 from this subscript or whatever, right? So this will also imply that when you have to do En, it is going to be
minus half.
Sorry? Yeah, n power, sorry, minus.
N plus 1 to the power
Minus
minus.
half. Right? Yeah, thank you very much. So this will become n power minus half. Then you'll have A plus acting on En minus 1. Correct? Then you can go further and you can say this implies that En minus 1 will be nothing but n minus 1 power minus half A plus En minus 2. Okay, you can keep writing this. So you can put this all together. Okay, so how do I put this all together? So I can write your En is equal to n to the power of minus half. Okay, then I'll do A plus of, instead of En minus 1, I will write over here n minus 1 to the power of minus half A plus En minus 2. Right? So this will be what? It will be nothing but n power minus half into n minus 1 power minus half A plus applied 2 times to En minus 2. Now what is this En minus 2? Using the same logic, we can write it as n minus half into n minus 1 minus half a plus whole cube, all right? Or rather, let's write it as square, okay, into n minus 2 power minus half, right? A plus en minus 3. Correct? I can keep writing it like this. Look at this. This is like a continuation of this. It will be the next step. Okay? So what will I get now? I'll get n power minus half, n minus 1 power minus half, n minus 2 power minus half. Then I'll get a plus applied 3 times on en minus 3. Okay? I can keep going like this. And finally, I can write your en is equal to, now what will it be? It will be n power minus half, n minus 1 power minus half, n minus 2 power minus half. Like that, all the way I can go down to 1 to the power of minus half. A plus to the power of n acting on E0. Okay, but look at this quantity here. This is going to be nothing but n factorial. All of you know factorial, right? N into n minus 1 into n minus 2 into all the way till 1. N factorial to the power of minus half a plus applied n times to E0. Okay, this is your En. So please, this is again a very, very important formula. Okay, I hope everybody's understood this. Okay, it's just an extension, all right, from here to here to here. You know, just keep extending it. This is what you will get. Now, what else do we need to figure out? What about A minus? Okay, so with A minus, we need to, you know, now that we know it for an plus 1, we need not worry too much. We can get it fairly easily. All right, so let's try it. We have over here your En. Okay, so I'm basically picking up this particular formula here, this one here, right? I hope everybody can see it. En is equal to n to the power of minus half a plus en minus 1. Okay, now what we will do is we will apply a minus on both sides. So apply a minus on both sides. Is that kind of visible? Ah, okay. So you will get now a minus en is equal to n to the power of minus half is anyway a number. We are going to ignore it. We'll have a minus a plus en minus 1. Okay, this is what we get. So now let's just write it down. I'm going to change the page. So what did we have over there? We had an a minus a plus, right? So let's just recall your Hamiltonian was equal to what?
Ma'am, next page.
Oh, sorry. Oh, good Lord, yeah. I hope I am not the only teacher who does this. I hope Meera ma'am also, you know, goofs up once in a while like this. Maybe you'll tell me she never goofs up. Okay. I'll be very embarrassed then. Yeah. Okay. So your Hamiltonian is going to be h cross omega into a minus a plus. And this was, I think, minus half, right? Minus half. Okay. So what does it tell us? It tells us then that your h by h cross omega plus half is equal to a minus a plus. Okay. So what did we have on the earlier page? Let us just go back once because I've lost track of it. Okay. We had essentially your A minus En, okay, was equal to n to the power of minus half A minus A plus En minus 1. Correct? Yeah. So now we will have n to the power of minus half, and instead of this A minus A plus, I will put over here h by h cross omega plus half into En minus 1. So this is going to give us now n to the power of minus half. We will have h by h cross omega acting on En minus 1 plus half acting on En minus 1, right? So what will this give us? This will give us n to the power of minus half, and here you will have h acting on En minus 1 will give us what? N minus 1 plus half h cross omega, right? Divided by h cross omega into En minus 1 plus half into the En minus 1 eigenstate. So now what happens? H cross omega cancel, and you will get n to the power of minus half. Here you will have n minus half En minus 1 plus half En minus 1. So just put it together, you get n to the power of minus half, and here you will get n minus half plus half En minus 1. So that will become now n to the power of minus half, and here you will get nothing but n, right, into En minus 1. So if you do n to the power of minus half into n, just 1 second, somebody is waiting to be admitted. What will you get? You will just get n to the power of half En minus 1. So this is how A minus acts. A minus acting on En is nothing but n to the power of half En minus 1. Again, very, very important to remember. So just let me put it up again. A plus acting on En gives you what? N plus 1 to the power of half En plus 1. So these two, please, please, please remember it. It will help you a lot. Okay. Yeah, this other thing, of course, I had derived earlier. This I just derived it now. Okay. This we had just done earlier. All right. So now there was an important question that I needed to answer from somebody as to what is the role of this n. Correct? Why is it that we name this a plus a minus as equal to n? Correct? Yes? Now I want you to remember this. You put h acting on En, you will get En. What is this En? It is nothing but n plus half h cross omega En. But I can write this Hamiltonian as equal to, what was that we had written at that point of time? H cross omega a plus a minus plus half, right? Yeah. And then we called it as h cross omega n plus half, correct? Now, I don't know who, I can't remember who asked this question. I think it was Tejashri. Yeah. So now, just 1 second, let me just admit. I think Kavya is having a little bit of trouble, poor thing. Yeah. Okay. So now let's put over here, instead of this h, I'm going to write it as h cross omega n plus half, okay, En is equal to n plus half h cross omega En, right? So now look at it, this h cross, these are just numbers. So I'm going to just cancel it out, okay, this h cross omega. So now we can write it as, let's open this up. You can write it as n acting on En plus half of En is equal to small n acting on En plus half of En. From both sides, you can remove this. This wave function appears on both sides. So what are you left with now? You're left with n acting on En is equal to n acting on En. So as you can see, so this is an eigen equation for the operator n. Okay. So thereby I'm going to change pages now. N acting on En gives you n. So what is it doing actually, this operator? This is this a plus a minus. It is giving you n, which is the level of the energy eigen state. Correct? So what you have to understand, that this has a special significance. It is sometimes called as the number operator. It tells you which energy level you're sitting at. Okay? A minus A plus doesn't have any such significance. I hope that answers your question. Tejashri, right? Is Tejashri around? Or you didn't get it? So let me stop the share. Did everybody get it? This particular thing, what is the significance of A plus A minus? Okay. And why A minus A plus does not do that? Okay. So A plus A minus is special. All right. It gives you the level of the energy operator. Okay. So now I have given you a whole bunch of things to, basically we have looked at what we can do with A minus and A plus, and it has obviously given us something very important, which is the energy eigenvalues, right? So we know that the energy eigenvalues En, okay, sorry, I should get back share again. Yeah, so what we have realized, that your En is equal to n plus half h cross omega, okay, and your E0 is equal to h cross omega by 2. Now these are extremely important, and what we realize is that this we have come to the conclusion from your ladder operators, right? So this is extremely important. Now what I want you to understand is that energy eigenvalues are not the only thing you can compute using your ladder operators. They are really, all you have to do is remember these two rules which I told you earlier. Okay. These two rules which I told you earlier. And you will find that you're able to calculate a whole bunch of things. Okay. Now for that you need to, it's a little important you understand how you can compute important things for you. Because you will say, ma'am, I'm not interested, I am interested in energy eigenvalues, yes. And then I may be interested in things like position, momentum, kinetic energy, potential energy. I may not be interested in, what A minus and A plus is able to do, until and unless it gives me some quantities, physical quantities, which make sense to me. And what makes sense to me? Energy makes sense to me. Position makes sense to me. Momentum makes sense to me. Okay. Now question is, can you calculate things like position momentum using ladder operators? And the answer is yes. How do you do it? Okay. So I want you to recall that your A plus is what? It is nothing but 1 upon root 2. And then what do you have over here? You have this m omega by h cross to the power of half, and this is with x, and then you have minus I 1 upon m h cross omega power half px, right? Similarly, you have a minus equal to 1 upon root 2, and then you have over here m omega by h cross power half x plus I 1 upon m h cross omega power half px. Correct? We have these two. This is how we defined a plus and a minus. Now it should be very simple for us to write x and px in terms of a plus and a minus. How do we do this? So for x, just let's add up a plus plus a minus. What will you get? You will get essentially 1 by root 2 into, you will get 2 m omega by h cross power half x, and the other two terms, okay, this term and this term will just cancel each other out, right? You're just doing a plus plus a minus, which implies that you will get a plus plus a minus. Here you will get root 2 m omega by h cross power half x. Now thereby we can say that your x is equal to, we will bring all this onto the other side. We'll have h cross divided by this root 2. I will take inside this bracket. Okay, I will take it inside this bracket. I will write it as 2m omega, the whole thing power half, into a plus plus a minus. So if you know how a plus and a minus works, you can definitely be able to figure out what happens to x. Again, a very, very important formula to remember. Okay. Now let's look at the other one. Okay. Let's do a plus minus a minus. What will we get? We will get, actually, let's not do it that way. Okay, it doesn't matter. Okay. We will, what will we get? We'll get root 2 into minus 2i, right? Minus 2i 1 upon m h cross omega power half px. Correct? We are doing a plus minus a minus. So now what will we get over here? So we can bring this minus sign to the other side, and we will get a minus minus a plus is equal to root 2 I, correct, 1 upon m h cross omega power half px, which implies that we will have we will bring this whole thing to the other side. Okay, what will we get? Okay, I shouldn't have bothered with the changing of the minus sign. It would have taken care of itself. So we will have over here m h cross omega by 2, correct? The entire thing half into 1 by I, a minus minus a plus is equal to px. 1 by I is nothing but minus I, right? 1 by I is equal to minus 1 into minus 1. Plus 1 can be written as minus 1 into minus 1. So this is going to be nothing but I into minus 1 divided by I. So I and I cancel. So it becomes equal to minus I. I hope you remember that. Hopefully that was not needed for most of you, but still. So therefore, we will have your px So that's why I was saying I need not have bothered with that minus sign. Px is going to be nothing but um, minus I m h cross omega by 2 power half a minus a plus. You can again take this minus sign in, and what will we get? Let me just get to the last page. Okay, I've overshot my time. Okay, so we will get now your px is going to be nothing but, let me just see, I into m h cross omega by 2 power half a plus minus a minus. Okay, very, very important. So let me just stop here. Okay, I'm going to stop the share. It may not be still clear to you how useful this is going to be. So tomorrow, okay, so I'm going to take your 4 to 5 class tomorrow. I think we talked about it last week and you said nobody else has booked you. Haven't sent you a message, but I'm going to send it to you now. So if nobody else has booked you, I hope nobody has. I'm going to take the 4 to 5 class tomorrow. So during that class, I will show to you how you can use the expressions that we have got for calculating something. And I'm going to give you all an assignment, okay, based on this. All right. Hopefully, then we'll be able to do the thing called pictures and wrap up formalism. I was hoping that we will definitely be able to do it by tomorrow, but I'm not sure anymore. Doesn't matter. We will then wrap it up and hopefully we'll be able to go on to the next unit from the next class onwards. All right. So, in the meantime, if there are any doubts, please ask. Any doubts, please? Any doubts? I think everybody's gone off to sleep.
No, ma'am.
No, good. So no doubts. Okay, good. So anyway, take care then, and we will see each other from 4 to 5 tomorrow in the afternoon. Okay? And if you have any doubts, even if you are not very clear about it right now, you're most free to ask it when we do the class tomorrow. All right? Yeah. So we will not do much of a recap. We will just start off with the, the calculations. All right? And as I said, I will give you an assignment based on that. Okay, then. So have a nice rest of the day. I think you have still one more class left to go. And I will see you all tomorrow at 4 o'clock. Okay, then. Bye. So I will stop the